In this video, we will see when a function is increasing and decreasing, and we will use calculus, more specifically the derivatives, to see where functions are increasing and decreasing. Increasing means if you increase the value of x, then its functional value must grow, must increase. If that is the case, then function increases. And if you increase the value of x and your functional value, the heights decreases, then that function is decreasing. And sometimes you have mix of both, where a function both increases and decreases, and we want to know in which interval our function increases and in which interval our function decreases, and so on. We will use calculus to know where function decreases and increases. If a function increases in some interval, then in that interval our first derivative is positive, and if decreases in some interval, then our first derivative is negative in that interval. Now let's write the precise definitions and then proceed to some of the questions involving increasing and decreasing of a function. We have a function f which is differentiable. That means we have its first derivative in some interval I. If its derivative is positive in that interval, for all x in that interval, then f is increasing in that interval. And if its derivative is less than 0, that means negative, then f is decreasing in that interval. Next, we will do some couple of examples where we shall use this concept to show where functions are increasing and decreasing. First, we have our function f as 3x cube minus 9x plus 1, and we want to find the intervals where f is increasing or decreasing. First, we will find its first derivative of this one. So first we have 3 times 3, 9x to the power 3 minus 1, which is 2, derivative of 9x, which is 9, then derivative of constant is 0. So this is our first derivative. Then we will make it 0 and find the value of x. So 9x square minus 9 is 0, which implies 9x square is 9. That implies x square divide both sides by 9, which is 1. So x becomes plus or minus 1. So x is either 1 or minus 1, where our first derivative is 0. Next, we will make a sign chart where we will take all the points, so where our function is defined, the whole domain. Here the domain is all real number line, and we will plot those 2 points, x equals to minus 1 and plus 1. Minus 1 comes left to 1, so first minus 1, then 1, and these 2 points divides our real number line in 3 parts. One is minus infinity to minus 1, minus 1 to 1, then 1 to infinity, and in each part we will see the sign of f dash. And to make that, we will pick one single point from each part and find the sign of first derivative. Suppose here we have 0, and we'll find the sign of 0, f dash 0. F dash 0 is, our f dash is 9x square minus 9, so f dash 0 is minus 9, which is negative. If at one point is negative, then at every point of that part our first derivative is negative. Then let's pick another point from here, 1 point. Here we have 2, clearly 2 is bigger than 1. What is f dash 2? F dash is 9 times 4 minus 9. 9 times 4 is 36 minus 9, which is 27, which is positive. So at all point in this part our f dash is positive. In this part, let's pick minus 3. So f dash of minus 3, 9 times minus 3 square, 9 times 9, which is 81, minus 9, which is positive clearly. So f dash is positive. So in this part our first derivative positive, here also positive, and here we have negative. So f increases, therefore f is increasing in, we have minus infinity to minus 1 open interval union 1 to infinity. And if it's decreasing, in -1 to 1. Next, let's solve another. We have fx is x cube, and we already know its behavior. Its graph looks like this one. So when you go towards positive x, and when you increase your value of x, your heights increases. So this function is clearly increasing in all real number line. It increases between -infinity to infinity, and this must be the case by the test also. Let's verify. What is our first derivative? It's 3x square. So x square is always positive for any x. So we can make it directly that 3x square is always positive for all x in the set of real numbers. So it is always positive. Hence, f is increasing in all real number line. Therefore, f is increasing in -infinity to infinity. Next, we have our function is x to the power 8 over 3 minus 4 x to the power 2 over 3. What is its first derivative? Take 8 over 3 outside, then x to the power 8 over 3 minus 1, 8 over 3 minus 1, minus 4 times 2 over 3, then x to the power 2 over 3 minus 1, 2 over 3 minus 1. So this is 8 over 3 x to the power 8 over 3 minus 1. So this is 8 minus 3 over 3 minus, this is also 8 over 3 x to the power 2 minus 3 by 3. So this is x to the power 8 minus 3, 5 over 3. Here we have x to the power minus 1 over 3. We can take 8 over 3 outside and write it as x to the power 5 over 3 minus x to the power 1 over x to the power 1 over 3, because this is minus. So next, we can add these two fractions. So in numerator we have x to the power 1 over 3, then they two will be multiplied. So x to the power 5 over 3 times x to the power 1 over 3 base x. So 5 over 3 plus 1 over 3, that is 6 over 3, which is 2, then minus 1. So this is our f dash. Now we want to make where our f dash is 0. So f dash is 0 when this whole quantity is 0. This is in denominator. So this goes to the 0 side. This multiplied with 0, which becomes 0. So we have x square minus 1 equals to 0. This is constant. So x becomes plus or minus 1. So f dash is 0 when x is either plus 1 or minus 1. Also, you have to find the point at which f dash does not exist. You have to find that point also. You have to find where our derivative is 0 and where our derivative does not exist. And here this function does not exist. Value of this quantity does not exist when x is 0. So we'll make that a note. F dash x does not exist when x equals to 0. Now in sign chart we will plot all these points 0, 1 and minus 1. So we have to make the proper order. We have first minus 1 from left, then 0, then 1. And these 3 points divide our real number line in 4 parts. And from each part we will pick one single points and check the sign of f dash. Let's check here. Here let us put the point, let's say it is minus 2. What is our f dash? Our f dash is this quantity, 8 over 3 x square minus 1 over x to the power 1 over 3. See, what is f dash of minus 2? When you put minus 2 here, this is 4 minus 1, which is 3. So this is positive, numerator positive, this quantity is positive. So what is denominator? Minus 2 over 1 over 3, which is negative. Square root, cube root of negative quantity is negative. So positive divided by negative is negative. So at minus 2, f dash is negative. That means at all the points in this interval, we have f dash negative. In this part, let us choose minus half. Minus half clearly lies between minus 1 and 0. So numerator minus half square, which is 1 over 4. 1 over 4 minus 1, which is minus 3 over 4. which is a negative quantity. So numerator is negative. In denominator, in place of x, we will put minus of. So minus of to the power 1/3. Cube root of negative is negative. So numerator negative, denominator negative. So negative over negative is positive. So f dash is positive. In 0 to 1, let's put 1/2. 1/2 in numerator. This is 1/4 minus 1, which is negative. That is minus 3/4. Denominator is positive. Cube root of 1/2 is positive. So negative over positive is negative. So f dash is less than 0. Similarly, let's put 3 square minus 1, which is positive, and 3 to the power 1/3 positive. Positive by positive is positive. So f dash is positive. See, you don't have to find f dash, you only have to check the sign of f dash. So here we have picked one single point, we have just checked the sign, we have not calculated what the exact value of f dash. So here we have f decreasing in, thus f is increasing in where f dash is positive in this interval and in this interval. So minus 1 to 0 union 1 to infinity, and f is decreasing in minus infinity to minus 1, f dash negative union 0 to 1.